our next presentation, let's welcome Matthew from Sustainea to the stage.
I'm just going to use this if you can turn these off. But how do I go forward? Just this one? Hello. Hey, everybody. Matthew Berdy. I am the Global Commercial Director from Sustainea. If you don't mind, I'm going to walk around a little bit. The idea of standing behind a podium, I feel like I'm just gripping on for dear life. So I'm going to roam, if that's okay with you. I apparently have the unenviable task of standing between you and lunch. However, in exchange for that, if you stick with me, I promise I'll do my utmost to not only make it informative, but also entertaining. So what is this low-carbon bio-PET solution that Sustainea is bringing to the market? Well, before I talk to you about that, you might want to know who Sustainea is. So if you sat in one of the earlier sessions with Braschem, Lucas introduced us. Thank you again for that, Lucas. Always a pleasure to get some recognition from our parent. We're a joint venture of Braschem and Sojitz to make Sustainea. And Braschem has been in this bioplastic space for a decade and a half, 15 years. So they've seen it. They've fought the battles. They've lived the life. They've taken on the scars. They've been through several cycles in an industry where one cycle often kills a lot of people. Sojitz, one of Braschem's very strong partners in Asia Pacific, when they saw this bio-MEG project coming along, they felt strongly enough about it that they wanted to invest in it. And hence Sustainea was formed as a spin-off of these two companies to drive this innovation to the market. So what makes it so innovative? If you're familiar with monoethylene glycol, it's a petrochemical. It's a petrochemical derivative, as many of them are. And it comes from petroleum, goes through many steps. You have a lot of carbon pickup as you do that, a lot of environmental inefficiencies. Massive scale, very well established. Additionally, even conventional biomeg processes, which are fermentation-based, go through a number of steps, starting with a sugar, going to ethanol, ethylene, ethylene oxide. Has all the same trappings of fermentation processes. Our process is catalytic in nature. So we start with a clean source of dextrose, and it's a one-step process to get from there to the bio-MEG. And in this case, we start with corn, which I'll talk about a little bit later, but what does that mean for the industry? It's a biomaterial with an incredibly high yield, it's incredibly efficient, and therefore it makes it much more cost-effective too. Not only that, but as many of the biomaterials, it's incredibly carbon friendly. So we sit here and say it's 80 to 110% less carbon than the regular fossil MEG. We don't know the precise number yet because, well, we haven't built the facility yet. I'll again get to that later. But compared to the fossil alternative, it's certainly, if you're looking for carbon reduction, an incredible alternative. And I'm going to go to this side of the room because I feel like you guys don't get much love over the course of the session. Everybody's down there. So I'll talk about the slide here. But the fossil MEG, the number we're comparing to is this one right here, that's 98%. That's the fair number. That's the global average when we talk about that reduction. Not all fossil MEGs are created equal. So there is a chance, if you're sourcing from China, that you're getting a coal gasified MEG. If that's the case, your carbon profile is over here on the left. It's pretty egregious, honestly. Now, if you're sourcing from China, period, that's almost half of all production in the world. And that's still quite a bit higher, albeit there's some dilution because coal gasification is not the only way to do that process. The global average, which we speak to, includes a lot of North American production, so that evens it out. But even in the case where you use a European source, which is a very small amount of the global production, 2%, you're still quite carbon heavy. And so when you look for that carbon reduction, that's where the bio-MEG comes in. Nearly carbon neutral. We'll see in a few years after we build the plant. I'll get back to you on that one. So what are the applications for bio-MEG, or MEG in general? Well, there's two big ones that we focus on. It's apparel with polyester fibers. So when you think about outerwear, tents, things like this, any synthetic fibers, polyester is one of the big ones, along with some industrial applications like tire cord, and of course PET packaging. I'm sure you hear a little bit about that when you talk about sustainability spaces. So Coca-Cola bottles, Pepsi bottles, I'm not trying to shout out any brands, but we all know them. Thermoforms, multi-layer films, these all go into this, right? So this is what we focus on. There's other channels of applications, but to be blunt, it's not economically viable for those when you talk about things like de-icing fluids, for example. However, along with our process, we do have a small co-production of a material called monopropylene glycol. This will most definitively be carbon negative, which anybody we talk to is always very happy to hear about that. About 10% of our production goes into home and personal care. When you think like detergents, sometimes even creams you put on your faces, this would be an application for that. So if you do have an interest in it, by all means, ask me about it later. Not really the focus because, again, our plant is really meant for monoethylene glycol. So let's talk about that plant. Where's the plant? Where's it located? What's going on with this? This is a $400 million investment greenfield project by Sustainea. So we're taking this seriously. We're putting our money where our mouth is. It will be located in Lafayette, Indiana, and it will be pipeline connected, co-located to our wet milling partner, a company called Premient. So why did we pick Premient? Well, we're serious about the value chain, the overall chain of custody when you talk about environmentalism, and Premient demonstrated to us that they're serious about this too. First and foremost, they just received their Energy Star certification. Any of you who were around in the 90s, God, I hate that I'm aging myself by even saying that. You may remember seeing on like televisions or computers this Energy Star certification. That's the same sort of certification, but I can tell you to get it for an industrial size plant, way harder, way harder. So the fact that they got it is enviable and braggable, which is why we bring it up. Additionally, they have their own decarbonization goals. They've already met 65% of their Scope 1 and Scope 2 goals for 2030. We, of course, help them with their Scope 3 goals since we're downstream, so that's one of the reasons they like to partner with us, along with diversification of use, which I'll talk about in a second. And they're focused on regenerative agriculture. So it starts with the plant. Corn is our ultimate source for this. And so we wanted to make sure this was also environmentally friendly. So this means minimal use of pesticides, no tilling, soil rotation, these sorts of things. The most environmentally friendly, economically viable agriculture that's available in the world, that's what they use. And that's what's important to us. In fact, to show further dedication, we're supporting 1,000 acres of regeneration in the area. We source all of our corn locally, it's with a 150-mile radius, to, again, minimize environmental impact, but also create more jobs and a better environment for the local economy to thrive as well, because we want to give back. That's important to us too. But let's talk about corn for a second, because we often get questions about this. To put it bluntly, maybe a little dramatically, Matt, are you starving babies? No. Definitively, we are not starving babies. But again, focus on food stuff is obviously a concern, as it should be. So we're more than happy to talk about why we don't actually take away from corn, we actually add to the value chain. Now, believe it or not, the main use of corn, the main reason people grow it, or companies grow it, it's not for supermarkets. So when you look into, you see cobs of corn, or you see cans of corn, or you see popcorn. 1% of all corn grown goes to those applications. The other 99% is what we call industrial corn. Industrial corn's purpose is for further processing to go into animal foodstuffs or human foodstuffs. And the big drivers for that, what they're trying to pull from that, are the protein and the fiber. Of course, they have these other components, one of which is starch, and from starch you get dextrose. We like dextrose, that feeds our process. Dextrose is often used industrially for ethanol for biofuels, and high fructose corn syrup, which sadly is a common sweetener in the United States. But high fructose corn syrup has been declining in usage by about 1.5% per year for the past 10 years, and it's projected to keep declining. People are moving away from these sugary soft drinks. So we're diversified use to feed our process, Let's say we didn't exist. Let's say that kept declining. Well, you got to do something with that starch, right? You don't not get to produce it. That means you have to dispose of it. There's a cost to that. Then you have to drive up the cost of the other components coming from the corn. So counterintuitively, we're actually helping to stabilize the costing and supply of corn by offering this outlet through the manufacturing of biomanufacturing glycol. Like I said, counterintuitive, but that's what it is. And so be glad we're using corn in this case because it actually helps to keep those nutrients flowing. Now, to further drive the point home, because I can't get enough of corn, I love it, I'm going to skip through this a little bit just to kind of get to the punchline. So the U.S. is a massive land area. A good chunk of it is arable land used for growth. Corn is 9% of that usage. So to feed our plant, which is a 200,000 metric ton capacity plant, it's quite large by bio standards, 0.009% of all arable land to power that process. Very, very efficient. Now, just to play a little bit of, fun mental math here, let's say you took all the fossil MEG out of the US and you replaced it all with bio-MEG. How much corn would you need for that? 0.06% of arable land would be required for millions and millions of metric tons of monoethylene glycol. That's how efficient the process is. How cut and dry is our chain? We start with the corn from the farmers. It goes to Premium, our wet mill partner, who makes the dextrose, who pipeline feeds it to Sustainea, who makes the biomanufacturing glycol through a one-step catalytic process, who then sends it on for further use for polyester fibers and PET plastics. The beauty is in the simplicity. The overall value chain, we've talked about a lot of them already. So the renewable feedstock, the regenerative practices, reduction of CO2. Here's the other two big ones I want to make sure you know. Number one, drop-in readily incorporable into your current process. You don't need to reformulate. Works exactly the same as a fossil MEG. You just get all the benefits of sustainability along with reduction of carbon. People like recycling. Fully supports that. It's not biodegradable. It's not meant to be. So any companies that are worried about recycling initiatives, zero effect, supports them entirely. In fact, we'd love to live in a world where you start with a biomaterial and then recycle it. That's what we're really aiming for. PPWR in Europe, for example, is supporting that, so that's what we drive for too. And if there's ever any doubt, C14 carbon tracking lets you know that it is what we say it is. Don't take our word for it. Third-party certifications, non-GMO verified material, TUV Austria, US certified bio-based product. We're working on more. These are the ones we have so far. Again, we want to make sure the market understands we're serious about this. We come from Braskem. We don't want to embarrass our parent. But more than that, all joking aside, we want to make sure we're doing the right thing. That's the whole reason why people and companies look at bio. So, I've given you all this great information. You might be wondering, Matt, when can I buy it? When can I get it? I want it now. I would love to give it to you now. I can't give it to you now. We're here, first half of 2026. This is our investment decision year. So we are actively going out and about, and we are looking for binding offtake agreements from companies, from brand owners. We've got a lot of them out already. We're, of course, looking for more. And assuming we get the green light from our board, and I'm telling you that I am busting my butt, as is the entire Sustainea team, to make sure that happens, we expect to start construction the start of 2027. It's a 2-year construction time, with material coming off the plant line beginning of 2029. So for those of you who are interested in this, by all means, we can start working through R&D now on your timeframes to make sure that when we're ready, you're ready. 10-year timeframe, we're going to build 2 more of these things. We're going to have 700,000 ton total global capacity. Where are those other 2 plants located? I don't know yet. My suspicion, probably not in the US. I'd love to see one here in Singapore. I like coming here. But yeah, that's what I've got for you today. So If you have any questions, by all means, scan the QR code. We have a booth set up at MS04 if you want to come and talk with the rest of the time we have left. Well, I've got food in my mouth, as we all will in a second during lunch as well. And that is exactly 15 minutes. Thank you.